Good evening, everyone. Thanks so much for joining us tonight, and welcome to Sappy Hour. My name is Jenna Quinn, and I'm the Conservation Science Manager with Ontario Nature, and I'm really pleased to be the moderator for tonight's Sappy Hour. So I'd like to get us started in a good way by just taking a moment to reflect and offer gratitude to our planet and nature and all the gifts that she provides us. It won't be long now before the snow is melting and the land and wildlife start to awaken around us. We'll start to see the trees bud and hear the sounds of the frogs calling and the birds singing. And my favorite butterfly will start flying, the morning cloak. And I know that a love of nature and birds is really what unites a lot of us and brings us here together. So I just wanted to express my gratitude and thankfulness to be sharing this virtual space with you all this evening. I'm joining from my home in Kitchener, which is on the Haldimand Tract, and it's the traditional territory of the neutral Anishinaabe and Haudenosaunee people. And I'm grateful to the stewards who now tried on this land and who then tried it on this land with care and responsibility for all its relations. And I'd also like to acknowledge that what we now call Ontario includes 46 treaties and other agreements. And of course, we are all treaty people with a responsibility to be active in reconciliation. So please feel free to share with us tonight where you're joining from. And if you don't know the territory you're on, it's a great place to start learning. We'll share a link with you in the chat to go to Whose Land. It's a great resource to help get you started. So tonight's Sappy Hour is on the theme of habitat change and monitoring. And if you've never been to a Sappy Hour before, then welcome. We're very happy to have you here. Sappy Hour is a play on the term happy hour, and it incorporates our Atlas mascot, the sapsucker. It's really just an opportunity to relax and unwind and learn more about the Ontario Breeding Bird Atlas. And you can check out all the recordings of past Sappy Hours on the Atlas YouTube channel. And similarly, tonight's Sappy Hour will also be recorded and posted to YouTube afterwards. Sappy Hour is a great opportunity to tap into the Atlas 3 team and ask any questions you might have. And so if you have any questions tonight for our presenters or also just about the Atlas generally, feel free to put them in the Q&A if you're tuning in from Zoom. And if you're tuning in from Facebook, you can write them right into the comment section and we'll pull some questions from there as well. So I have the pleasure of now introducing our two speakers for the evening. First up, we have Remy Tarenta. Remy is a bird biologist who obtained a PhD in ecology from Moncton University. After 8 years of work experience with forest birds in Eastern Canada, Remy has been the British Columbia Projects Coordinator for Birds Canada since 2021. His talk tonight is entitled Atlas Data, Understanding Distribution Changes and Conservation Applications in Canada. And we'll see how the collection of data contributes to large data sets like the Atlas and how that's been used to assess occurrence and abundance shifts in wood thrush across Ontario and Quebec. So welcome, Remy. I'll let you take it away and we'll hear from Mike following.
Thank you very much. So I'm going to share my screen and hope it's going to work. All right, can you share my screen? Can you see my screen, sorry?
Looks good.
Perfect. So yeah, thank you for the introduction. I'm very happy to be here, talk about Atlas data. I love data and understanding their applications. So today, I'm going to present about some work I've done during my PhD, and I'm going to illustrate the importance of these large-scale data sets with four examples of ways that Birds Canada staff and other conservation practitioners may use for conservation. So the first example, using Atlas data for understanding species distribution changes, and this may in turn influence management decisions at the scale of landscapes or forest management practices to enhance habitat. And I'm going to take the case of the wood thrush, which is one of my favorite species in Ontario, and I'm sure a lot of you are already familiar with it. And the last three examples I'm going to take come from my colleague, Doug Tozer, who is not here today, but among other things, he analyzes data for the Great Lakes Marsh Monitoring Program. So some of you might know him if you participate in the marsh monitoring. So I'm going to talk about using Atlas data for measuring the conservation value of lands. And also we'll take the example of Atlas marsh bird data for COSIWIC assessments and advancing joint venture priorities. So first of all, back to almost 10 years ago when I was writing my third chapter during my PhD, a chapter about the wood thrush that I finally published a few years ago. So the results I will present today only represent a little part of investigating spatiotemporal patterns and dynamics in wood thrush breeding populations. So as you probably all know, the wood thrush represents very well the decline of our forest birds in North America, and the reason why it has been designated as threatened under the Species at Risk Act is this very worrying negative trend across its range. So it's minus 50% observed since the 60s, huge decline. Here I just show a map. I don't know if you see my pointer, but you have the north of the range here, of the wood thrush breeding range. And then I'm going to focus on two ecoregions, the Canadian Shield, which is at the periphery of the range in Ontario and Quebec, and the St. Lawrence lowlands. So the main questions I was trying to answer was how has wood thrush range and population changed across Canada for the past decades? Are populations changing differently in different parts of the range? How can we explain those changes and those differences between ecoregions? And are these populations, these sinks, demographic sinks in the St. Lawrence lowlands maintained by immigration? So a part of Atlas data answered part of these questions. Here you have the three large-scale breeding bird atlas data I've used to quantify these changes for the wood thrush. So you recognize here the Ontario breeding bird atlas, and here you have the second Quebec atlas and the second Maritimes breeding bird atlas. If you're not familiar with the way we present those data, here a square with a point that represents a local extension between two atlas periods. So usually it's like about 20 years between two atlas periods. So for example, here in Ontario, you see at the north of this map, you can see a lot of local extinctions, apparent local extinctions, because we can never sample the whole the whole area, of course. So what did we find when we looked at this atlas? So we quantified the extinction rates in atlas squares, and we found out that the local extinction rates were nearly 5 times higher at the periphery of the breeding range, which is the Canadian Shield. So all these areas here in Ontario and here in Quebec are mostly, or not mostly, but like 29% of this area is local extinction. In contrast, if you look at the St. Lawrence lowlands, which is theoretically a better habitat quality for the wood thrush, you can see that between the two atlas periods here in Quebec and Ontario, you have a lot of red, orange. So the occurrence patterns have remained remarkably stable in the lowlands, despite declines everywhere else in the range. So we tried to understand why. Why is it so apparently stable in these lowlands? And of course, we can summarize all these three atlas data by saying, okay, well, we observed a contraction of the wood thrush range at the periphery, at the northern edge. So I went farther and I tried to quantify mature forest cover in atlas squares and their influence on occurrence patterns of the wood thrush. And so I quantified this amount of forest and changes in forest cover between the two atlas periods to determine their influence. So what did we find? Here is what I found. For example, I took the example of Ontario. I found overall a significant influence of the amount of mature forest, significant enough to account for the variability we observed in the occurrence patterns in the atlas for wood thrush. However, as you can see on this graph, the strength of this effect depended on the ecoregion. So here, the Canadian Shield and the St. Lawrence Lowlands. So at the periphery of the range, the Canadian Shield here, you can see that the probability of detecting wood thrush in both atlases increased with the amount of forest cover on the Canadian Shield, which is supposedly less optimal habitat. So in other words, the influence of the variable forest cover varied significantly between regions. And in Quebec, it was a little bit similar. So this basically revealed that higher cover of mature forest might compensate for lower quality habitat at the periphery of the range for the wood thrush. And this is because soils are much more acidic and they are expected to host a lower biomass of invertebrates in the litter. These invertebrates like snails that have high calcium content. So the acidic kind of cancel the amount of calcium in the soils. And so you have less prey for the wood thrush to feed on. So to compensate for lower quality of the habitat, then maybe higher forest is needed at the landscape scale. So that was pretty interesting. In addition to Atlas data, I've been able to use other large-scale data sets. So I'm just going to show you an example here with a forest bird monitoring program, which is different. It's a different type of surveys. It's point count data. So what was interesting with this data set is that it shows trends in relatively undisturbed forest tracts in Ontario. So what we found out when I summarized all the data from the 90s to nowadays, we found that wood thrush was almost 2 times more abundant in the lowlands, at the top of the graph here, than in the forest of the Shield, the Canadian Shield, which is at the bottom of the graph here. Almost 2 times more abundant. We can also notice significant declines in both regions, but they're actually declining at a faster rate on the Shield, so at the periphery of the range. Also, what was very interesting to notice was this slight increase here for the lowlands. And we linked this increase in abundance to this 1998 ice storm that occurred it occurred mostly in the lowlands. And what the ice storm did is that after the ice storm, you had a sort of regrowth of this dense sapling layer that wood thrushes really like. And so this regrowth has definitely benefited the species. Overall, these additional results showed that, like detection data, like the Atlas data versus count data from this, for example, add different information. So what we found to be like stable trends for wood thrush with the Atlas data actually was not a really complete information. So with these point count data, we were able to say, okay, well, maybe Atlas data were not revealing that population trends are actually not that stable or less stable than we thought. And the reason why, even in the lowlands, you have these declining trends is because of what happened, on the wintering grounds, the deforestation and the different factors that have negative effects on the wood thrush. So I could say during my thesis, those trend results may point towards the effect of factors operating during the non-breeding period because all these data were mostly collected in undisturbed large forest tracts. So if you don't have, or if you have very few effects on the breeding range of the habitat, then maybe it's something else. And the something else, of course, comes from the other part of the life cycle for the birds. So to sum up what I found out with Atlas and other large-scale data sets, if you take the breeding range and if you compare populations near the core of the range, so for example, the St. Lawrence lowlands, we saw a sort of apparent tolerance for mature loss and fragmentation. So this is because of natural disturbances that may improve habitat quality, but also like the fact that the habitat loss and fragmentation has occurred since the 19th century. So it was very historical. Like there's not much more big loss of forest in recent years. And also in parts of the range, there is also like local reforestation. Another reason why they appear tolerant is because of maybe immigration from larger forest tracts around that sustain these fragmented populations. Because we know that populations in the lowlands are still affected by the effects of fragmentation that bring more predators and more cowbirds that affect the breeding success. So to explain this, we also showed during my PhD that there is actually some immigration that sustain those fragmented populations. If you take populations at the periphery of the range, they look more prone to local extinctions over the short term. And this is because it's marginal habitat, you have the limiting conditions, the fact that climate change is pushing population towards the north, but at the same time, the forest at the north is not changing fast enough for wood thrushes to adapt. So that creates a sort of barrier for extension of the range to the north because of climate change. There is also a recent forest loss at the periphery and less likely rescue effects from these population sinks. So it was very interesting. And of course, you add to all these effects, the deforestation that's still happening on the wintering ground, and that affects all the different populations across the range of the wood thrush. What is interesting is how do you apply these findings? So we made recommendations to land managers at different scales. So for example, at the landscape scale, we recommend maintaining connectivity between source and sink populations, protecting blocks of high quality breeding habitat, especially, well, not only in areas with high forest cover, which is we think it still represents a big source of immigrants, but also in landscapes with low forest cover, it's really, really important to protect those little fragments to promote the persistence of the birds. At the forest scale, the habitat scale, of course, we recommend appropriate forest management practices that favor forests that are structurally diverse, especially with a well-developed shrubby understory, because the wood thrush loves to nest in this understory that is often created by like the fall of trees or other disturbance. So this is called habitat enhancement. So that was one application of Atlas data. And so I'm just going to quickly mention other examples. So Atlas data, they are invaluable as a very, very good standardized source of data for quantifying the conservation value of lands. Some of you might be familiar with what we call the Ontario's green belt. So all these patches of good habitat and forest. And right now, the Ontario green belt seems somewhat secure at the moment, but to provide an additional tool to defend its value in the near future, we actually plan to bring, or my colleague Dr. Ozo plans to bring together the data from the Ontario Breeding Bird Atlas, but also the Ontario Reptile and Amphibian Atlas, and also the mammals, and potentially other similar data sets to show what we might lose if we develop these lands on the Greenbelt. So how can we do this? We can do this by comparing various metrics based on Atlas data in the Greenbelt to those in nearby developed areas like the Greater Toronto area, for example. So if you compare metrics in the Greenbelt and metrics in very developed areas, and if you find that, for example, like species richness is higher or species abundance is higher, then you can show the value of these lands. Another example, breeding bird atlas data often fill voids in information in northern areas where other programs are basically like non-existent. Here I take the example of the marsh monitoring program. As you can see, there are big knowledge gaps in northern areas. You probably saw that in other presentations. So in Ontario, what Doug is doing, they're piloting the Atlas Marsh Bird Survey. And the goal of this Atlas Marsh Bird Survey is to fill knowledge gaps left by the marsh monitoring program. Because, of course, this program is excellent for the coverage in Southern Ontario, but it has always been sparse in Northern Ontario due to the lack of participants. So why do we need this information in the North? It's because we need to regularly assess the status of species at risk in Canada. So the organism in charge of this is the COSIWIC, the Committee on the Status of Endangered Wildlife in Canada, and they need reliable estimates of the total number of individuals of a species throughout its entire distribution. It's one criterion that is used for these species at risk assessment. So we really need these estimates that can be calculated based on models from Atlas data. And I just wanted to pinpoint that atlases provide one of the only means of getting this data. If they didn't exist, we would not be able to reliably estimate population sizes. So in the end, if the Ontario Atlas Marsh Bird Survey is ultimately a success, then we plan to replicate it during other future atlases across Canada. Last but not least, conservation planning by migratory bird joint ventures as part of the North American Bird Conservation Initiative is another example of where estimates of total population sizes and trends are needed throughout entire provinces. But again, getting this information is a no-go without dedicated monitoring in the North as well as in the South. So how does it work? The joint venture begins conservation planning by stepping down population objectives from continental and national bird conservation plans to the specific joint venture region. And then these regional population objectives are translated into habitat objectives through a scientific process that I'm not completely familiar with. It's described in the joint venture implementation plan and in the bird group strategies. But basically, they use a lot of habitat models and they translate regional population objectives that come from, in part from Atlas data, into habitat objectives. So here I just show the example with Sora, a marsh bird that you're very familiar with, and the population objectives by the Upper Mississippi River and Great Lakes joint venture. As you can see on the map here of the joint venture region, there is a pretty good coverage in the south of Sora's breeding range by eBird, marsh monitoring, and breeding bird survey routes. But what do we need? We need atlas data that would come to the rescue in filling all these voids in information that we have, in particular in the north of the range, which is not shown here. And these large-scale data will be used to make estimates of total population sizes and trends. And then all this information, all these estimates will inform the specific regional objectives and conservation strategies by each joint venture. So that shows you why these atlas data might be important for conservation planning. On this note, I am already done with my presentation. So if you have any questions, please feel free to drop them in the chat. And thank you very much for your attention.
Thanks so much, Remy. That was great. And it's really great to hear you, make the case for how important Atlas data is. I know that's something we all agree on here on this side of the Zoom call, and I'm sure on the other side as well. So thank you. And as Remy said, if you have questions, please pop them in the chat, pop them in the comment box on Facebook, and we will circle back after our next talk. So I'll welcome Mike Burrell. I'm sure a familiar face to many here tonight. Mike grew up with a strong interest in birds and has worked for organizations like Birds Canada, Long Point Bird Observatory, Ontario Ministry of Natural Resources and Forestry, Ontario Parks, and Canadian Wildlife Service. Mike's home position is with the Ontario Natural Heritage Information Centre, where he's the provincial vertebrate zoologist tracking Ontario's biodiversity. Mike's talk tonight is on the use of Atlas data to track changes in rare species across the province. Atlas data play an integral role in filling gaps in the distribution of Ontario's rare bird species. And for species such as the cerulean warbler, Atlas data are especially important for updating and assessing the status of element occurrences, or areas of land and water in which a species or natural community is or was present. So welcome, Mike, and take it away. Looking forward to your talk.
All right. Thanks, Jenna, and thanks, Remy. That was awesome. Yeah, it is great to be here. You all, a lot of you likely know me, but you know me from one of the hats I wear, which is the Atlas coordinator. I'm going to take this one off. Look at this. I brought props. I'm going to put on a different hat for the next 15 minutes or so. I'm going to tell you about what I do with what I'm looking forward to doing with all this Atlas data after the Atlas is done and I'm back to my regular job at the Natural Heritage Information Center. So, quick outline. I'm going to tell you a little bit about the NHIC, the Natural Heritage Information Center, which is where I normally work. And then I'm going to talk a little bit about the importance of citizen science generally and how we use that citizen science data. And then I'm going to finish off with why the Atlas data is just so important to the work that the NHIC does and ultimately conservation of the species we all love so much. So the NHIC is a unit within the Ministry of Natural Resources and Forestry, and we are tasked with basically tracking rare species. So we talk a lot about rare species, all sorts of other kind of related things, like endangered species and protection and conservation. Those are all topics that are top of mind for us at the NHIC. We do all sorts of work with conservation partners. So we work closely with Birds Canada, with Ontario Nature, Nature Conservancy of Canada, just to name a few of the conservation partners that we work with to track Ontario's biodiversity, especially the things that are rare. So as I said, we're a unit within the Science and Research branch of the Ontario Ministry of Natural Resources and Forestry, but we're also part of this network of 82 natural heritage programs that are across the Western Hemisphere. So there's more than 80 different programs similar to ours in different states, provinces, and countries in South and Central America. 14 different countries are represented in the network the last time I checked. And the really cool thing about that is we all are part of this organization called NatureServe, represented in Canada by NatureServe Canada. And because we're part of a network, we follow the same protocols that the other programs follow as well. And so we follow this international protocols, and we do things in a similar way. And that way we are able to share notes about how to do things in the most effective way when it comes to tracking rare species and biodiversity in general. But then we're also able to compare our data that we hold. So then we're able to look at, okay, what's the status and how is the species doing here in Ontario? How does that compare to our neighbors to the east, west, north, or south? And what can we learn from each other? And then we can also look at how we can basically roll up the information we have to national or international scales. So one of the main roles we have of the center is to maintain a dynamic database of the important sites for rare species of plants and animals and plant communities and other special natural features in Ontario. So we do that by collecting information, whether it's observations from other people or our own, and then we transform those things into something that we can use to eventually provide meaning to what's happening out there and eventually inform how we can protect and sustain our environment. So I've mentioned a few times about talking about data and collecting. We are basically a house where we hold a lot of information about where those rare species are. We get that information from a variety of sources. Traditionally, we got most of that information from museum specimens, literature records from old journals and things like that, or directly from researchers. We get a lot of information still, and we always have, from field surveys by professional biologists. Includes from within the provincial government, from other levels of government, from various agencies across the province. So we get a lot of our information from those sort of traditional sources. But increasingly, we have seen the emergence of just how important citizen science data is for tracking rare species especially. So we've seen a rapid increase over the last sort of 10, 20 years, especially as internet and cell phones made collecting that information much easier. That citizen science data now makes up well over 40% of the rare species data that we hold on to. And the real key players in terms of where those citizen science data are coming from are atlases. So the breeding bird atlas being the biggest, but we've got atlases on reptiles and amphibians, butterflies, dragonflies, mammals, and then increasingly mobile tech platforms like eBird and iNaturalist play a really big role in terms of where we're getting information about rare species. So we maintain our database. It's not just birds. Birds make up over a quarter of the information we hold, but we have a lot of information about other groups of animals and plants, lots of reptiles and amphibians, lots of plants, lots of mammals, but we track rare species of all different types of taxonomic groups. As I mentioned earlier, citizen science data is increasingly important for the data that we hold on to. This is a few years old now, this figure. It was at 43%. It's probably well over 50% now of the data that NHIC has comes from citizen science. So it's a hugely important factor when we're looking at where those rare species are. So we're gathering up all this information. What do we do with all of those observations? We turn them into what we call element occurrences. Jenna mentioned that at the start when she was introducing me. An element occurrence is just, I'm going to read you the plain old boring definition of what it is. It's an area of land or water where a species or plant community is or was present. The important part is they represent an area that's important to the conservation of a species or plant community, such as a courtship, nesting, rearing, and feeding areas of a bird. So the important things here are that it's an area that's important to the conservation. So it doesn't necessarily include the bald eagle that you saw flying over for your backyard. It's got to be some sort of site that's got importance for that species. So how do we create it?
Sorry, Mike, you're just a little bit quiet right now.
Sorry. How do we create our element occurrences? So we gather up all of that observation data that we can find, and then we have our team of experts at the center that review that information that meets the criteria. So going back to that last slide, is it an important spot for that species? So when it comes to birds, this is really important because, as everybody that's on this call knows, birds have wings and they tend to use them fairly regularly. So just because we have a record of an observation of a bird at a location, that doesn't necessarily mean it's an important site for that species.
Sorry, Mike, your audio is cutting out a little bit here. Yeah, there's some folks that are just sitting there not able to hear you.
All right.
It sounds different than when it usually cuts out. I don't know why.
Okay. Yeah, my fan's on, but I can't do much about that. Let me quick try my headphones here. Bear with me here, folks. Sorry. All right.
Try again?
Is that any better?
Oh yeah, that's way better.
Okay, cool. Should have just done that right from the start. Okay, so when we gather all that observation information, then we're going to have the review by our experts to determine whether that observation is a potential addition to an element occurrence. So is it a suitable site for that species, and is it important? So for birds, that basically means, is this a breeding location? So that's your first kind of hint in terms of why the atlas is so important. We're going to come back to that point shortly. So we have that review, and then we use standard specifications. And remember earlier on I mentioned that we follow standard protocols that are used by all these different data centers across the Western Hemisphere. So we use standard specifications for that particular species, or often it's a group of species. So there might be one set of specifications for warblers, for instance, rather than one for each different species of warbler. So we look at those specifications to make sure we're doing things the same way other centers would in terms of whether that site qualifies. And then we're going to look at where does that observation fall in relation to other observations that met that criteria. And then also, where does it fall in relation to suitable and unsuitable habitat? So this map that you've been staring at for the last couple minutes, this is an example. We've got a whole bunch of observations. Each one of those little circles is a location where, let's say, a cerulean warbler was observed at some point over the last 25 years. These are all part of the same woodlot, that green outline, and some of them are very close together. So this is this becomes one particular element occurrence. All those observations are informing this element occurrence. Essentially, you can think of it as this is one site where that species that's important for that species. So you going back, if you remember that definition of an element occurrence. Basically, it's a site for this particular species that's important for the conservation of that species. And we could have hundreds, thousands of records of observations that are attached to one particular element occurrence, and they just basically dissolve together to make one shape that you see there. You can see the boundaries of those individual observations have been dissolved. So why are atlas data so important for us when we're developing our element occurrences? So first of all, they're extremely high quality. They're collected during the breeding season, which is very important for birds in particular. And extra important is we've got breeding evidence attached to those records. So we know not only whether there was breeding evidence observed, but we know what level of breeding evidence it was. And this can be really important depending on the species and the individual specifications that we have for that particular species, what kind of breeding evidence we need to decide whether or not that's good enough for an element occurrence level. They're also very precise when it comes to locations, and you'll remember lots of our Atlas Sappy Hours. Kaylin and I have been pleading with everybody to make sure you keep pinning those locations for rare species. Those are the really valuable things when it comes to these element occurrences. To know exactly where that species was on the landscape. And then Remy kind of touched on this in his presentation. The Atlas is really focused on not just getting records from the same hotspots that people go to year after year, but getting records and observations made throughout the entire province. So those are all super important factors, what make the Atlas so important. So I wanted to show you an example. So I picked one of the most common species that the Atlas detects, white-throated sparrow. And I wanted to show you one other source of data that's really important for us. So this is the map that shows eBird records during the peak breeding season over the last 3 years before Atlas 3 started. So 2018 to 2020, this is peak breeding season. There's a lot of Atlas squares where white-throated sparrows were recorded. So you might think, well, why do we even need the Atlas? We got eBird, it's doing a pretty good job, and it does a great job. Absolutely. But here's the map of Atlas 3. And you can see, I'll just flip back and forth a couple times. You can see the Atlas is, and all of you folks on this call, you're helping us really fill in those holes that we would have if we were just relying on eBird. So we're filling in those holes. And more importantly, if you drill down a little further and look at that information, so the number of squares obviously is much higher. Almost 1,000 more squares have been covered in the first 3 years of the Atlas than the last 3 years of eBird use before the Atlas started. Number of records is almost twice as many during the peak breeding season. And then the really huge one is the number of breeding evidence records that have some sort of breeding evidence attached to them. Not even 1,000 records in eBird, and then almost all of them, so about 24,000 records, have some sort of breeding evidence attached to them during the last 3 years of the Atlas. So hugely important to fill in those holes geographically, but also to get that extra level of information that we really need to help us assess those observations and know just how important they are for the conservation of the species. So I got a couple other examples I'm going to show you. This is a look at the Atlas 3 map for black tern so far. And we actually did this analysis last fall. We looked at our element occurrences for black terns, and then we looked at our nice recent data from the first 3 years of the Atlas. And we're finding that of all those locations that we've ever had an element occurrence in the province for black tern, only about 20% of them appear to be occupied during Atlas 3. So we've had a huge loss in breeding sites of black tern. And because we've got this high quality information for a species like black tern that can go far distances from its breeding sites, the Atlas data is extra important because we've got that breeding evidence. So we know whether was this just a bird that happened to be at a pond, or is this actually tied to some sort of breeding site. So super important example with black tern showing a big decline. Another way that we use Atlas data especially is when we're assessing the status of an element occurrence. So not only do we map and kind of keep track of where those element occurrences are, but we also need to know how are those individual element occurrences doing? How are those sites doing? And so we use Atlas data more so than any other data source to look at the health of a particular site. So when we've got all the information about what's happening at the site, how many records are there, what's the breeding evidence, then we're able to use that information to assess the status of individual element occurrences. And we did this also just fairly recently for cerulean warblers. So when it comes to the Atlas data, it's very, very important when it comes to how we update our element occurrences. And then those element occurrences they have huge number of uses. They're used by our conservation partners. They're used by federal and provincial governments for making decisions. They're used by land trusts about where they want to acquire land or target places for acquiring new land. We use those element occurrences for land tax incentive programs. Remy talked about it tonight. Danielle talked about it in great length at our last Sappy Hour. The data can then be used for species status assessments. And the other one that I wanted to focus in on here was the species habitat protection piece. And it's well and good for us to be able to assess the status of a species and say this species is endangered or this species is threatened. But when it comes to protecting the species, especially its habitat, we need to know where are those species and what habitat are they using. And that largely comes from NHIC's element occurrence database. And without big projects like the Atlas making huge contributions, we wouldn't have the information we need to, in the first place, develop those element occurrences, and in the second place, assess the status of those particular element occurrences. So just another one of our many important uses of the Atlas. When it comes to your contributions, you're making a big difference. And I will end my presentation there.
Thanks so much, Mike. That was great. And really, I think the maps you show really kind of dramatically highlight how many people participate and how important, the power of people is for these Atlas projects. And as working conservation professionals, I think we all know and appreciate we can't do it alone. We would never be able to collect this data without this amazing group of people that participate. So thank you to everybody that's tuning in tonight and that's participated in the Atlas. The data is going to great places, as we saw tonight. So put your questions in the chat. We have a few minutes. So if you have any questions for Remy or Mike, or just questions generally about the Atlas, we also have Kaylin here tonight that can answer any burning Atlas 3 questions. So definitely let us know. There is one question already, and I think it's directed to you, Mike. So from Liv, is there a minimum number of observations needed in order to have an element occurrence?
Yeah, that's a good question. Again, I'll go back to there's specific specifications depending on the species we're talking about. Generally, it's more than one. So we wouldn't make an element occurrence generally if it's a one-time breeding event. So, an Acadian flycatcher shows up in my backyard and maintains a territory for the whole summer. That doesn't really represent a location that's that important for the species, perhaps. If it comes back year after year, then we start to see a trend. So it really is species specific. But yeah, generally more than one. Successive years are better than not, but it depends on the species.
And how often are element occurrences established?
It depends on the species. So I didn't mention it, but the NHIC has about 13 staff, and we track not just birds, so all different species. So we tend to get our marching orders from higher up in government as far as the species needs to be updated because there's a pressing conservation need. It might be that the species is going to get reassessed, or there's going to be some sort of habitat protection measures put in place. So it really depends on the species. Those high priority species tend to get done more frequently than others. Some of the species we track, they might never really come around to us doing like a deep dive into where they are. We maintain the observation side of things and have it ready at our sort of disposal to work on the element occurrences. But yeah, it really depends on the particular species and the priorities we're given in a given year.
Thank you. There's a question from Kelly. who says, my interest is in mute swans. I know from the Marsh Monitoring Program recent report that they are declining inland. Can you speak to what inland refers to if you are saying Northern Ontario is not well covered with various counts?
Yeah, I think here's the answer, is about the scale. So inland here, I think refers to inland marshes versus coastal marshes. So I don't think it's related to how far north the data are collected. But if you have a specific question about the Great Lakes monitoring program, maybe you can ask Doug Tozer. He'll be able to confirm. But yeah, I think it's inland versus coastal marshes.
Great, thanks for that clarification. Lynn is asking, and I don't know if anyone wants to speak to this generally, but does someone want to talk about Ontario's endangered species protection and the strength of those policies?
Yeah, that's a pretty hard one to answer in the short amount of time we have. I will say the Ontario is one of the not all provinces even have an Endangered Species Act, so it's there, and there's some great tools, but that's outside of my expertise for sure in terms of how it's applied and that sort of thing.
Thanks, Mike. And there's great tools for people to use to make their voice heard to the government. If you want to speak out about something being important to you, there's lots of platforms to be able to speak to your MPPs or comment directly on policy changes and things like that. Some questions about the Atlas generally in the chat. Gary wonders if wilderness outfitters and clients are encouraged to submit observations and sightings. Is there any sort of direct outreach to maybe not a non-traditionally birding community?
This is for Kaylin, I think, or Mike.
Yeah, I can jump in, but Kaylin, feel free to jump in also. So I'm not sure if that question is asking if the NHIC does that, or we're talking about the Atlas in general. I'm going to answer it from the Atlas in general's perspective. We've done a bit of outreach to sort of those non-traditional areas, and we've asked RCs to, some RCs are putting up postcards in like cottage country, general stores and things like that. We've talked to a few here and there, but there's a lot of them, and it really has depended on like if the opportunity arises, we do, but we haven't done that I can think of a sort of coordinated approach to that.
Great, thanks. And I think everybody that's viewing tonight, everybody can have a role to play in spreading the word about the Atlas and drag a friend out to, an event or show them how to use nature counts. And you never know, that maybe is the next Atlaser ready to go. A question from Angie. I'm curious how data analysis corrects for the tendency of rare species to attract observations from many people. For example, a single observation of a rare species may attract dozens or more people to come see it, and there'd be many records in eBird or nature counts of that individual bird. Is there a statistical way to control for that?
So I'll answer it from the NHIC perspective, and then I can attempt an Atlas one too. But from the NHIC perspective, for really rare things, that's sort of like the human interpretation comes in, and that's why we talk about things often at that element occurrence level. We're talking about an area, and there might be 1,000 observations, or there might be like 5 observations within that area of land or water. So in that sense, when we're talking about rare species, it's usually easy to take care of that, because if it's rare, then we're probably looking at that stuff very closely and often like with a manual kind of lens. So we're not just like dumping all that information in. if you were looking at something like eBird, you'd see like these huge spikes in their standard products, like their bar charts. So, like I'm in Peterborough. If you go look at the bar chart for boreal chickadee in Peterborough, you could get the idea that the next few weeks is like the prime time to go see boreal chickadee, because we had a boreal chickadee at a feeder a couple winters ago, and everybody went and saw it. So it can skew those things, but I think when we get to advanced sort of in analysis, like we'll have with those atlas maps that we saw last week from David Isles, they'll be able to account for that stuff, at least to a degree. But I don't know, Remy or Kaylin, you guys probably know more about stats than I do. I know you know more about stats than I do. So if you have a specific thing you want to add there, but there's a lot of smart people that are going to work on that stuff. So I don't have too many worries.
Just wanted to add, usually about analysis, it's there is always a correction for sampling effort. So if a rare bird attracts more people in an area, then it's going to be taken into account using a metrics about sampling effort. So the more people make observations, it's going to be accounted in the analysis. If that answers the question. I also wanted to add that a lot of rare birds, especially on eBird, for example, are kind of protected. Like the exact location is not revealed. It's the case also for data platforms like NatureServe. Not everyone can access those, so I think it's a good thing, to not drive too much attention in these locations. But there is always, things like the rare bird species alerts that drives tons of people in one place. But hopefully that doesn't disturb analysis, I don't think.
Great, thank you. And I think, Mike, you highlight a really good point, and humble brag, you probably didn't mean it, but there's a lot of people behind the data as well that are vetting it. And, it's not just data and numbers that nobody's looking at. These are individual birds, and somebody's validating them and making sure that it makes sense as well behind the scenes, which is really important. An anonymous question: any species that are being targeted, any sort of in particular species that you're hoping people are submitting sightings of in the atlas?
Yeah. Well, that's the cool thing about the atlas, is we're interested in everything. But we do, anytime you're opening the Nature Counts app or using the web data entry, or even on our the data forms you can download from the web page, they all have a little status. So the rare species in a given area would be flagged. So the rarest things are the birds we call provincially rare species, and on any of the data entry platforms that you might use, it's this little dagger symbol. So those are the rare species. Those are the, like, you can go home and have a glass of wine or a beer or buy yourself a cake or something anytime you find one of those. But yeah, we're interested in everything, and if you find those, it's great. Document it, add those pins every time you find them. But yeah, those are, we're not really targeting specific species for the most part.
Great, thanks so much. Really great to hear everyone's questions and get those answers. I apologize if we didn't get to your question. I do see a couple more in the chat, and so I encourage those folks, especially if your question's very specific on protocol, or if you're just generally wondering how to get out and get involved with the Atlas, definitely email atlas@birdsontario.org. You'll get connected to the right people to keep asking questions and keep getting those answers. There's also a great website, Discord server with lots of information and a way to kind of keep the conversation going also. So check out all of those resources. And a reminder that this Sappy Hour, along with all previous Sappy Hours, are posted to the YouTube channel. This one will shortly be posted. So if you missed any, or you didn't get to make it all the way to now, then circle back and watch them. And That's everything. Good night. We really are pleased that you joined us this evening. Tune in next Thursday, February 22nd for the next Sappy Hour. It's going to be on Atlas data and land use management. Should be a good one. So I'll just turn it over. Mike and Remy, any last words before we sign off tonight?
No, thanks everybody for coming, and thanks Remy for your presentation. It was great.
Yeah, thanks, Mike, for talking about elemental currents. And I wanted to thank all the participants. Your contribution really, really makes a difference. So great job, everyone.
Thanks so much, everyone. Have a great night.
Bye.
Bye.